Hi everybody! In this tutorial we will see how we can import OpenStreetMap's data into Houdini. We are going to create a basic setup where we generate buildings as simple shapes and create streets based on imported lines. At the end we will also see some little extras, and as always you can find the tutorial related links in the description, including also the scene file. If you like to learn Houdini, subscribe to my channel in order to stay updated for the upcoming videos. So, let's get ready! First, we are going to download our OpenStreetMap file containing all the streets and building information which we can import later in Houdini. On the web page, we can search for our location. For this tutorial, I took the Manhattan area out of New York City. After you zoomed in to define the area you want to work with, we can go up here to export it as .osm file. Click again Export to start the download. This works perfectly fine, but it is not allowing you to export larger areas. In this case, I would use as alternative QGIS, an open source software for geographic information, including also OpenStreetMap's data. After downloading and installing it, we need first to implement the OSM tool in order to get our data. QGIS is in my opinion not the most user-friendly software, but if you are using any alternatives to obtain larger scale OSM files, please share it down in the comments. That said, let's go to the plugin tab, and we're going to install 3 plugins. First, the locator filter, allowing us to search locations in the OpenStreetMap. Then the OSM downloader to obtain the OSM file, and the quick map service to load the map. After this operation, you need to restart the program. Next, we open the OSM maps. Go to Web, Quick Map Service, OSM, and we choose OSM Standard. It is automatically added a layer and opened the OSM map. Down here in the corner, we can search for our location. Make sure that the OSM function is listed here. It states that in order to search for our OSM location, you need to finish the line with a space. We type New York and hit space in order to get the results. To zoom, you can use the magnifier value down here. 80% works fine for me. To save it out, press this button here and select the area. Save file and click OK. Having now our files, we jump in Houdini, and at first we download the SideFX Lab tools, which we will need for this tutorial. You will find the tools here under Shelves, SideFX Labs. Click Update Toolset and Update again. In order to find them, you need to restart the program. Perfect. This toolset is very handy for game dev workflows, like for example exporting to Unreal Engine and Unity, exchange data between other programs like ZBrush, Substance Painter and so on. And it is also a very useful tool for mesh processing and world building. Let's start by placing a GeoNode, and inside we import our OpenStreetMap file via the OSM nodes from the SideFX Lab tools. You can find the node in Labs, Import and OSM Import. Here navigate to the file. With spacebar and G, we can zoom in our selected node in the viewport. It might happen that you will not see anything appearing. And this is because your viewport camera clipping is not set right, or the imported geo is too big. To change this, you can access the Properties window by hitting D in the viewport. Here we can find all settings relating to the appearance of the viewport. Under the View tab, you can find the camera clipping settings and either use the Auto Adjust or setting it manually. What is important here is to have a very small number for the near clipping plane and a high one for the far one. Something like this. And I would also like to change the background to dark under the Background tab. The first thing we notice here is that it also took the extensions of the main streets exceeding our predefined area where the buildings are. We want to clean this out and center it on the origin of the workspace for better handling. First of all, we cut out from the rest the area which we are interested in. For this we create a geometry from which we cut the lines. Change to the top view up here. And manually create 2 corner points via curve. Drop down a curve node. And now you can interactively click and place points in the viewport, creating a curve. Make sure that you have the gizmo handle selected. And then hit ESC to stop drawing. Once you have the curve, go to the coordinates and make sure that the Y value is set to 0 to have the curve lying flat on the ground. Next we use a bound node to create a bounding box from the curve. In order to obtain the box, increase the lower and upper padding. Now with a group node, we select all the points inside our box. Connect the lines with the first input slot. Here we set the group type to points and we use a bounding region. Make sure to disable base group. And to use our custom volume, we specify here use bounding object. Now connect the box we just created to the second input of the group node. Next we add a blast node in order to delete the points from our group. And we delete the non-selected items. Perfect. So to place now our map in the center of the world space, we use the axis align node from the lab tools. What we want to do is to place it in the center and flat on the ground by its minimum Y value. We conclude this step by adding a null node and name it out OSM. As next step, we extract the buildings and their heights. Drop down the OSM filter. And here we deselect the roads and keep selected the buildings. Now we need the OSM buildings node. Plugging in our geometry, we see that the building height is way off. To fix this, we could either scale the whole map to adapt it to the right units. I personally prefer to keep it in a reasonable grid space, because later on it might be easier to work with other values from different nodes. Therefore, drop down a transform node and in the scale Y value, divide it by 1000. So we finalize it with another null node and we call it out buildings. Now that we have the buildings, we are going to create the streets. We use again our OSM filter node. This time we disable the buildings and select only the roads. We just use the primary roads. What we're going to do now is to create a script which generates streets based on these curves. Our first step is to extrude the lines to surfaces. Therefore, we need to define the curve's extrusion direction in form of a vector. For this, we will do the following steps. First, we create a vector which follows the line from point A to B. Then we create a vector up and obtain the perpendicular one by the cross product of both. The cross product is a mathematical operation which takes two linearly independent vectors and gives as a result the perpendicular vector from both. The resulting vector is the one we need as direction for the extrusion. To begin, we need to split all the lines in unique primitive segments. By switching on the prim numbers on the visualizers here, we can see that some parts form together one primitive. To split them, we use a carve node. Here, we enable both the first and the second U parameter, which allows us to split the line at the beginning and at the end. First U we set to 0 and the second to 1. Then we go to the breakpoint tab and we enable cut all internal U breakpoints. Before we create our vectors, let's clean up all the attributes and groups of the geometry to work better. To do so, use the attribute delete and the group delete node. Here you could type in specific attribute names, and by typing in the asterisk sign, you delete all containing elements. We do the same also for the group attribute. Because we are going to create the corresponding vector and extrusion individually for each single line, we need a for each primitive loop. This evaluates one primitive at a time and performs the operation that we define inside here. The output will then be again all primitives merged back together. When we highlight this, we see that it starts with the prim number 0. Here, drop down our VOP node and plug the line to the first input. We dive in, and now we individually import the 2 points by using an import point attribute node. The point is a vector 3, and as input source we have input 1. The attribute we need is a position vector of the point P, and by switching on the point number visualizer, we see that we need a point with the number 0 for the first one. With a constant node, we can set the number. In our case, for the point number, we need an integer, and we can leave it to 0. We copy the node for the second point and change from 0 to 1. Now by subtracting both points, we get the vector indicating from one point to the other. Normalize it in order to have values between 0 and 1. As next, we create a new vector pointing up. For this, we use a float to vector node. Here, for the y value, we use 1. And now that we have these both vectors, let's create a cross product. Type in cross product and drop down the node. We plug in our 2 vectors and normalize the output again. We will use this new created vector as our point normal. The normal vector is in Houdini defined by the attribute n. For visualization purposes, we also output our other 2 vectors. Drop down a bind export node and plug in the normalized vector resulting from the subtraction. We export also our second vector by copying the bind export node. And this one we can name vector up. The bind export node is creating a new point attribute containing the created vectors in each point. By diving out, we can display the normal vectors and also create custom visualizers for our other 2 vectors. This is not an essential step, but it is always very important to visually check in the viewport what is going on in your script. I use visualizers a lot. If this topic is new to you, you can check out my tutorial about visualizers. I will put the link in the description. By right-clicking on this icon in the Scene tab, we can add new visualizers, here on the plus icon. In this case, we choose Marker. Give it a name and a label, and then choose Vector. The attribute is our vector line, and additionally you can also adjust the color and the length. So something like this. Now repeat the same also for the second vector. Checking through the lines, we can see that we succeeded with our script. We move on by extruding the line with the polyextrude node. Drop it in the for each loop, and here make sure to use point normal and that we use the existing normal attribute we just created. In the output category, we only check output sides because we only want to create a single surface. We can specify the extrusion amount here, and this value works fine for me. but of course it might vary depending on the scale of your model. Copy the node and do the same for the other half of the street, in order that the surface looks symmetric to the middle. In order to keep everything procedurally, we link the two values together. Right-click here on the parameter and select Copy Parameter. Then here right-click again and say Paste Relative References. And to make it negative, we simply multiply it by -1. The advantage is that we only need to change one value, and the other one will adapt automatically. Combine both with a merge node and connect it with the exit node of the for each loop. So what we see is that one side is flipped. To fix this, we can add a reverse node. To fix the shading mistakes, we can add another normal node at the end of the chain. This will recompute the vertex normals. So far it looks correct to me, but what we see here are open gaps. This happens because we treat each polyline individually and disconnected from one another. As the last step in the for each loop, we close them by adding a circular surface to each point with the diameter like the street width. We place a circle node, set it to polygon, and we orient it to ZX. Paste also here the extrusion value in the uniform scale to scale the radius automatically. For better looking results, I also want to increase the division to 24. To copy this circle now on each point of the curves, we use a copy to point node. Plug in the circle in the first input slot and the points we want to copy the geometry to in the second input slot. Let's add this to the merge node. The problem here is that we have two circles for almost each point. I will quickly show this by moving up one of the circles. This is because each endpoint of a polyline is the starting point of the next one. In this way, it automatically places a circle twice on each position. We can fix this by deleting one of the 2 points for each line element before plugging it in the Copy to Points node. Drop down a Delete node and say Delete by expression. And we say add ptnum, which stands for the point number, equals to 0. This is telling it should delete the point with the point number 0. Remember that the lines come in separately, and therefore each segment will have again the point number 0 and 1 for the start and end point. Quickly testing it again out here, we see that it worked. Perfect. If we have a problem with the face orientation of the circle, we can simply rotate it in X by 180 degrees. As next step, we can clean out the circles and the overlapping surfaces in order to get one clean surface. Add an extrude node and recompute the point normals with a wrangle node. And here we type @n, which stands for the normal attribute, and equals. In curly brackets, we create the vector 0, 1, 0 for the up direction. Close with a semicolon, and now in the extrude node, set again point normal as extrude mode, and we use the existing normals, which we just created. Here now check all output options. And for the distance, 0.01 works fine for me. Now let's add a Boolean node and set it to union in order to create one clean object. We are now going to use this extrusion to cut out the streets from a clean plane. Here the bound node is again very handy to automatically generate a plane which is big enough to be intersected with the extrusion. What we need is a single surface, so we can set it to rectangle. Also, we add some upper and lower padding in X and Y in order to make the plane and the extrusion properly intersect. In order that the plane goes through the middle of the extrusion, we use a transform node to move the plane in Y. Here we can subtract the half of the extrusion height. So we use a second Boolean to intersect them both. This time we set it to intersect, and input A is a surface. For the shading problems, we use again a normal node. And now we see our new clean surface. Let's conclude our script with another extrude node to get the street height. This value worked fine for me, and this looks very clean, and we reduced the amount of polygons quite a lot. Finally, we conclude by placing another null node and name it out street. In order to save out the geometry result step by step, we can right-click on the geometry node and go to Save Geometry. Now choose the directory, and for the file format we use bgeo. Each street topology we can re-import with the file node. And then merge them all together. The street topologies that we need for the city are primary, secondary, tertiary, and residential. What I experienced is that due to the elevated number of the residential roads, these cannot be processed at once. Therefore, we will go through a procedure where we see how to separate the elements into different areas to compute the street step by step. So we can use a new OSM filter node and select only the residential roads. We also copy the attribute delete and group delete node to clean the geometry from unneeded attributes. What we want to do is to cut these lines into 4 or more portions and to keep only one area at a time. Here we can find a very useful node in the SideFX Lab category as well. Take the multiple bounding node. We see here that when we plug in the lines, nothing happens. The problem is that the node is not working with totally planar geometries like our lines. We need to dive in the node and find out what went wrong. Unlock the node by right-clicking and allow editing of content. You will see the little lock icon in the bottom right corner turn red and unlocked. Now we can dive in and go step by step through the node. Already at the beginning of the script, we noticed that because our geometry consists only of planar lines, the box node is creating a lot of overlapping surfaces, because there is no height value for the box to be extruded. In this case, a plane would be the correct solution. Replace the box with a bound node and set it to rectangle. After the first for each loop, the script is generating again some double surfaces. What you need to do is to disable the polyfill node. Its function is to close the sides of the cube after being clipped. Because we just have a surface, it is resulting in a mistake. We also skip the next for each loop, because this one is calculating the split in the y direction, which we don't need. In the third for each loop, we disable again the polyfill node, and by highlighting the output, we are ready to go. Out here enable the isolated index option, and now we can skip through all the 4 bounding boxes. Additionally, depending on the power of your computer, you can also change the amount of splits up here. So this is perfect. And lastly, I will also change the node's color and appearance, so that I remember that I changed it inside. In order to split and trim these curves on the borders of the different areas, we use a curve sect node. We plug in both our street lines and the region. When we highlight the points in the viewport, we see that we created a new point on the intersection position. As next, we drop down a group and a blast node. where we select the points inside the region and delete the ones outside. The group type is point and enable the bounding region and select bounding object. The needed bounding volume can be created again with a bound node and by adding some padding in Y. This is pretty handy and adapts automatically. When we zoom in, we see that it is not including the points which lie exactly on the border of the box. Therefore, we need some additional padding. Make sure to use a very small value, like for example 0.01 in my case, in order to not include other close points. Select the group in the blast node and select Delete Non-Selected. This just created group we can delete again with a group delete node, so that everything stays clean. Now we obtained the right amount of lines for our street generation script, so that our computer might not crash. Here we would have the option now to plug it directly in the script we created before, or copy the whole thing and reuse it. In this tutorial I want to show you a more elegant and efficient way, by converting this into a single node where we can exploit parameters on the parameter panel. This step can be done by copying our script and converting it to a subnetwork with the box icon here in the corner. Many nodes in Houdini are nothing more than a summarized script, which we can open and learn how they are done, and also change like we did with the multi-bounding node. Dive inside and what you see are 4 input nodes corresponding to the 4 node inputs of the subnetwork. Here inside, the node which will be highlighted will be used for the output. We plug in the input 1 in our carve node and jump out to test our script. Perfect. The advantage in combining a script in such a node is the reusability. For this we can expose the parameters, which we want to be changeable in the script. At the moment we see in our parameter panel the input labels. We want to expose here the parameters we want to use to drive the script. To customize this interface, we select simply this gear wheel icon and set Parameter Interface. In this window we find 3 columns. One shows the parameter options that we can use to create the parameters in the panel, like for example float values, integers, vector values and so on. The second column represents our parameter interface. The third one shows the option available we can give to each parameter we created in the panel. As first step, let's get rid of these input labels, which we don't need. Select them and click Invisible. To find them again, you can select here, Show Invisible Parameters. The main way to create parameters is by adding a parameter value, as for example, we want a parameter to change the height of the street. This value is a float number. We select here float value and drag it into the second column. Give it a name and a label, like street height. And the type stays float. Now we can create a slider with a specific range. In the case of my model, I would go from 0.02 to 0.01. Give it a range, which works best for the scalar from model. In my case, these are good values. Hit accept. We see we just created our parameter, but this is actually not doing anything. This is because we need to link this value to the height extrusion value in our network. As you might expect, we right-click on the parameter and say Copy Parameter. Dive in the subnet and go to the Poly Extrude node, where we right-click again and say Paste Relative References. Further, we would also need the street width. This time I want to show another way how to create these parameters. We open again our parameter interface, but this time dive inside our subnetwork and search for the corresponding parameter, which lies here in our Poly Extrude node. Remember that we already linked the circle and the other extrude node with this value. Now simply drag and drop the distance parameter into the column. We name and label it, and also set the range to the values which work best for you. For me this is fine. And now we create a very simple but intuitive node we can reuse in our project again and again, without going through the script all the time to find the corresponding parameters. In the case of our residential streets, I would like to have these ones half as big as the other ones. To get the final model of all the streets, we save out each part by changing through the indexes. And then re-importing them again. In the next tutorial, I'm gonna show you how this saving out process could be automated in order to save time. To conclude, we merge the parts together and use a Boole union to clean out the overlapping parts. Now let's see the result with the buildings. Drop down a merge node and plug in both together. Keep in mind this is a very basic setup. Of course we could add more elements and details like facade, walkways, building elements and so on. Let me know in the comments if you would like to move on with this setup and in what you would specifically be interested in. Now at the end I would like to share with you some extras. I'm going to show you how to add your just created street building node in the node menu so that we can add it easily in a new Houdini file without copy-pasting it from an old one. For this, select your subnet node and go to Assets and New Digital Asset from Selection. Name it accordingly and hit Accept. So now when you enter the node menu, you will find the Street Builder node here in the Digital Asset tab. This applies of course also when you open a new Houdini file. Now as a short practical example, I drew here some simple lines in Rhino, which I'm going to export as DXF. For me it works fine to export all lines as polylines. And then inside Houdini, I use a file node to import the lines. Rotate them by 90 degrees in X and plug them in the new created Street Builder node. In this simple script, we create only streets based on lines which lie on the ground plane. In order to apply these streets on different landscape topologies, I'll show you a simple method how this could be done. It is not the most correct method, but in most of the cases it works completely fine for me. As fast solution for a 3D topology, I'm extruding the streets in order to intersect the topology, to then make a Boolean intersection between them both again. At the end you can also extrude the streets and give them a color. Perfect. So, I hope you enjoyed the video and to see you next time. Ciao!